Imagine a giant invisible blanket wrapped around our planet. That's our atmosphere, a sea of air composed of countless tiny particles. These particles constantly move and collide, creating a force we call air pressure. Think of a balloon. When inflated, the air inside pushes against the rubber, creating pressure. The Earth's atmosphere works similarly. The weight of all the air above us pushes down, creating air pressure. We don't feel this pressure constantly because our bodies are accustomed to it. However, we experience its effects in various ways, from the way our ears pop at high altitudes to the power of a strong wind. Understanding air pressure is crucial to comprehending our weather, the science of flight, and even how our bodies function. Air pressure isn't uniform across the globe. It varies depending on temperature and altitude. This variation creates areas of low pressure and high pressure, constantly interacting in a dynamic dance. Warm air is less dense and lighter, causing it to rise. As it ascends, it creates an area of low pressure beneath it. Think of a hot air balloon. The heated air inside makes it buoyant, causing it to float. Conversely, cold air is denser and heavier, causing it to sink. This descending air creates an area of high pressure. Imagine a cold air mass settling over a region, bringing with it clear skies and stable conditions. This constant interplay between low and high pressure drives our weather patterns, creating everything from gentle breezes to raging storms. Air pressure is a key player in determining our weather. Understanding its role helps us predict and prepare for changing conditions. Low pressure areas are often associated with unsettled weather. As warm air rises in a low pressure zone, it cools and condenses, forming clouds and precipitation. This is why stormy, rainy weather is often linked to low pressure. On the other hand, high pressure areas are associated with calm and clear weather. As cold air descends in a high pressure zone, it suppresses cloud formation, leading to sunny skies and stable atmospheric conditions. Weather maps often depict low pressure areas with an L and high pressure areas with an H. These maps help meteorologists track weather systems and forecast future conditions. Section 4. Taking Flight: How Airplanes Master the Skies. The marvel of modern aviation is a testament to human ingenuity and understanding of the natural world. Air pressure is fundamental to the physics of flight. It plays a crucial role in how airplanes achieve and maintain altitude. Airplanes utilize the principles of pressure difference to achieve lift and soar through the air. This principle is what allows these massive machines to defy gravity. An airplane's wings are designed with a special shape called an airfoil. This design is critical for creating the necessary lift. This shape causes air to flow faster over the top of the wing than underneath it. The difference in speed is key to generating lift. This difference in airspeed creates a difference in pressure. Lower pressure above the wing and higher pressure below. This pressure differential is what lifts the airplane. This pressure difference generates an upward force called lift, which counteracts gravity and allows the airplane to stay airborne. Without lift, flight would be impossible. By manipulating the shape of the wings and the speed of the airflow, pilots can control the amount of lift generated. This control is essential for safe and efficient flight. Understanding air pressure is essential for pilots to navigate different weather conditions, altitudes, and air densities. Mastery of these elements ensures a smooth and safe journey through the skies. Section 5. Air pressure's impact on our daily lives. Beyond weather and aviation, air pressure influences various aspects of our daily lives, often in subtle ways we may not even realize. From the way we breathe to how we cook, air pressure is a constant yet invisible force at play. Our bodies are adapted to the average air pressure at sea level, which is why we feel most comfortable in these conditions. When we travel to higher altitudes, the lower air pressure can cause discomfort such as ear popping, headaches, and shortness of breath. This is because our bodies need time to adjust to the reduced oxygen levels. This is why hikers and climbers often experience altitude sickness in mountainous regions. They need to acclimate slowly to avoid severe symptoms. Air pressure also plays a significant role in cooking, affecting how food is prepared and cooked. At higher altitudes, water boils at a lower temperature due to reduced air pressure. This means that cooking times can be longer, and certain recipes may need to be adjusted. This can affect cooking times and require adjustments to recipes. For instance, baking might need lower temperatures and longer durations. Even the simple act of drinking through a straw relies on air pressure. It's a perfect example of how we use air pressure in everyday tasks without even thinking about it. When you suck on a straw, you create low pressure inside the straw, allowing the higher atmospheric pressure to push the liquid up and into your mouth. This basic principle is a small but fascinating demonstration of air pressure at work. Section 6. Beyond the forecast, the wider implications of air pressure. The study of air pressure extends beyond everyday life and into realms of scientific exploration and environmental monitoring. Meteorologists use sophisticated instruments to measure air pressure changes, providing valuable data for weather forecasting, climate modeling, and understanding long-term atmospheric trends. Monitoring air pressure is crucial for tracking storms, predicting severe weather events, and issuing timely warnings to protect lives and property. Furthermore, understanding air pressure variations in different geographical locations and altitudes helps scientists study atmospheric circulation patterns, air pollution dispersion, and the overall health of our planet's atmosphere. Section 7. Conclusion. Air pressure, an invisible force shaping our world. Though invisible to the naked eye, air pressure is a powerful force that shapes our world in countless ways. It is the unseen hand that drives weather patterns, influences climate, and even affects how we breathe and move. From the fury of a hurricane, with its devastating winds and torrential rains, to the gentle lift of a bird's wing as it soars through the sky, air pressure is a fundamental aspect of our physical environment. It is the reason why planes can take off and why we experience different weather conditions. Understanding the principles of low and high pressure allows us to comprehend weather patterns, appreciate the marvels of flight, and even recognize the subtle ways air pressure influences our daily experiences. For instance, the way our ears pop when we change altitude, or how a storm can suddenly change direction. As we delve deeper into the science of air pressure, we gain a greater appreciation for the intricate workings of our atmosphere and the interconnectedness of Earth's systems. This knowledge not only helps meteorologists predict the weather, but also aids in understanding broader climate changes. From the smallest atom, where air pressure affects molecular motion, to the largest weather system, air pressure is a constant reminder of the invisible forces that shape our planet and our lives. It is a testament to the complexity and beauty of the natural world.